Okay, so I'm going to solve a couple of problems using Newton's second law, F equals ma, and we're going to use this law to see if we can see the relationship between force, mass, and acceleration. So in this first problem up here, number one, it says how much force is needed to accelerate a 66 kilogram skier at 2 meters per second squared. So using Guffs, we'll start out with our given. So we're given the mass is 66 kilograms, and we're given the acceleration is 2 meters per second squared. And if that's the case, I can use the formula. Oh, first of all, F is my unknown, GU, F. And I can go to my formula. F is ma. Force is mass times acceleration. So it's going to be 66 kilograms times 2 meters per second squared. And 66 times 2, well, 60 times 2 is 120. 6 times 2 is 12. 120 and 12 is 132. And now look at the units. It's kilograms times meters per second squared. And we have learned that a kilogram meter per second squared is equal to a Newton. That is the definition of a Newton. If you take 1 kilogram and make it accelerate at 1 meter per second squared, that's 1 Newton. So this is 132 newtons of force. So that's how you do this, this first problem up here. Next it says, I'm going to skip down here to number 3. I'll go to a darker color as well. Do number 3 next. What is the acceleration of a 50 kilogram object pushed with 500 newtons of force? Well, we know that our mass is 50 kilograms, and we know that our force is 500 newtons. So there's my givens. My unknown is acceleration, so I don't know what that is. Acceleration is question mark. And now I can look for a formula. Well, I know from my previous formula up here, F equals ma. If I solve that for A, acceleration is force divided by mass. It's F over m. So I divided both sides by m to get F over m. So now I can substitute in. And for my force, I'm going to have 500 newtons. But instead of writing newtons, okay, I wrote newtons in there, but instead of including newtons, I really should write that as kilogram meters per second squared. So I've got my eraser right here. I'm going to erase the newtons, and instead I'm going to write kilogram meters per second squared. That's equal to a Newton. And the reason I'm going to do that is it's going to help me do my unit analysis. And now I'm going to divide by the mass. The mass was 50 kilograms. So now when I go to solve the problem, 500 divided by 50 is 10. And notice that the kilograms down here cancel with the kilograms up there. And once again, I am left with meters per second squared for my acceleration, which is the appropriate unit. So whenever you have a Newton, you can always make that Newton into a kilogram meter per second squared. And the kilogram meter per second squared will help you to do unit cancellation. So there's the first two. I'm going to erase the board here for a quick second, because we're going to do number 7, and I'm going to scroll that problem up. All right, here's number 7 in this set of problems. And it says, a bowling ball is rolled with 15 newtons. So my force is 15 newtons. And it accelerates at 3 meters per second squared. So there's my acceleration, 3 meters per second squared. And a second ball is given the same force, but it goes at 4 meters per second squared. So for the second ball, acceleration is 4 meters per second squared. So for each of these balls, I'm supposed to figure out what is the mass. So again, we know F equals ma. That's our starting formula. If I divide both sides by a, I'm going to get that mass is equal to force divided by acceleration. And if I substitute in 15 newtons over 3 meters per second squared, 15 divided by 3 is 5. But once again, a newton is a kilogram meter per second squared. Kilogram, instead of newtons, I can write kilogram meter per second squared. And now, the meters per second squared cancel out, and I'm left with 5 kilograms. So the bowling ball is 5 kilograms. Well, this next one rolled faster, so it must be lighter. So let's see if we can prove that. The mass is still F over A, but this time I'm going to use, again, my 15 newtons, but instead of writing newtons, I'm going to write kilogram meter per second squared. I'm going to divide that by an acceleration of 4 meters per second squared. And now I've got 15 divided by 4. Jacob, what's 15 divided by 4? Can you do that for me?
I should probably know this.
That's okay, it's not even. Notice again my meters per second squared cancel. What'd you get?
3.75.
3.75, and it's going to be in kilograms because the meters per second squared cancel. So the ball that had the greater acceleration was in fact lower in mass, because mass resists acceleration. And up here, the acceleration is 3, had to have a higher mass because that would have more inertia. It would have more resistance to acceleration. So this is how you solve problems using Newton's second law of motion, F equals ma.